Logical connectives. What is logical connectives? Logical connectives are used to combine simple propositions to form compound statements. Compound statements are composed of two or more simple statements connected by logical connectives, such as and, or, if, then, not, if and only if, and exclusive or. Now, what is a proposition? Proposition is a declarative sentence that is true or false but not both. A proposition is only answerable by true or false, not yes or no but true or false. Here are some examples of proposition. Mount Apo is the tallest mountain in the Philippines. It is a proposition and true. Please give me some water. Not proposition because it is not answerable by true or false. X is a real number. Not proposition because x doesn't have a value. X is greater than 5 if x is equal to 3. Proposition but false because 3 is not greater than 5. 1 plus 1 is 2. Proposition and true. It seems logical connectives are complicated, but they are not as long you understand it very well. Now, there are 6 main logical connectives. First one is conjunction, followed by disjunction, negation, implication or conditional, by conditional, and exclusive or. Conjunction. All you need to know is that when it has a false value, it is a false, and this is the symbol used in conjunction, meaning and. Here are some examples of conjunctions. A dog has a tail and a wings. False because dogs don't have wings. We made pancakes, eggs, and coffee for breakfast. False because coffee for breakfast is not answerable by true or false. The Philippine national tree is narrow and the Philippine animal is carabao or water buffalo. True because the national tree and animal of the Philippines is narrow and carabao. I am a boy named Ted and I like dogs. False because I like dogs is not answerable by true or false. P is true and Q is false. It has false value, that's why it's false. Disjunction. It is the opposite of conjunction. Disjunction, when it has true value, the answer will be true. And this is the symbol used in disjunction, meaning or. Here are some examples of disjunction.
Negation. If P is true, but P is false, meaning the true value of the negation of a proposition is always the reverse of the true value of the original proposition. Example number 1. P is true, I like to sing. The reverse value of P is false, so that not P is false, I don't like to sing. Number 2. P is true, John is here. The reverse value of P is false, so that not P is false, John is not here. Number 3. I have something to tell. P is true. The reverse value of P is false, so that not P is false, I have nothing to tell. Number 4. P is false. Ami did not eat rice. The reverse value of P is true, so that not P is true, Ami ate rice. Number 5. P is false, not P is true.
Conditional propositions. A proposition of the form if P then Q or P implies Q represented by is called a conditional proposition. For instance, if John is from Chicago, then John is from Illinois. The proposition P, if John is from Chicago, is called hypothesis or antecedent, and the proposition Q, then John is from Illinois, is the conclusion or consequent. Note that P implies Q is always true except when P is true and Q is false. So, the following sentences are true. If 2 is less than 4, then Paris is in France. If London is in Denmark, then 2 is less than 4. If 4 is equal to 7, then London is in Denmark. However, the following one is false. If 2 is less than 4, then London is in Denmark. Here are some examples of conditional propositions. Biconditional propositions. Biconditional propositions are compound propositions connected by the words if and only if. It can be written in the form P, if and only if, Q. The symbol for if and only if is a triple bar or a double-headed arrow. The rules in biconditional propositions say that the only instance wherein it becomes true is when both component propositions have the same truth value. Thus, if one is true and the other is false, or vice versa, then the biconditional proposition is false. Here are some examples of biconditional propositions.
Exclusive or. It's always false when P and Q are both true or false. And it's true when P and Q have a opposite value. Sample number 1. 0 is less than 1, 3 is less than 5. This statement is false because P and Q are both true. Number 2. 0 is equals to 0, 1 is equals to 1. This statement is true because both P and Q have opposite value. Number 3. 8 greater than 7, 2 is greater than 1. This statement is false because P and Q are both true. Number 4. 10 is equals to 5 squared. 10 is equals to 2 times 5. This statement is true because P and Q have opposite value. Number 5. 3 squared is equals to 9. 3 raised to the third power is equals to 9. This statement is true because both P and Q have opposite value.
Thank you for watching. Hope you learned something.